Hello, my friends, and welcome back to class here in Online Human Anatomy and Physiology 2. So this week, we are continuing our investigations into learning more about the symphony of the human body and the smaller, lesser-known interactions that you may have started to observe as we progress through the material throughout the semester. So this week we are going to conduct an investigation, and this investigation actually carries on from our exposure to this body system in Anatomy and Physiology Part 1. So if this is new content, you're still going to be supported in meeting your learning outcomes. But we are going to be taking a look at the endocrine system. And the endocrine system contains all the organs and the glands that secrete and produce hormones. In Anatomy and Physiology Part 1, we were all about being able to understand that hormones do exist in our body. This is where we really get into investigating which glands are going to be supporting and producing what, how we identify them, and also how they interact with our body based upon our lab experiment. When we take a look at the endocrine system, I've actually pulled up my inner body uh, OER resource right here, and we can see that there are some structures visible. Um, so when we take a look at the endocrine system, the big thing is it's all about maintaining homeostasis. The body will secrete hormones that will allow for homeostasis to occur and allow our bodies to be great. And these hormones are just chemicals that are distributed throughout the body and control a lot of the vital biological processes, ranging from growth, development, metabolism, even our sleep and awake patterns are all guided by these different structures and glands. So we can actually take a look at this body structure right here. I am going to pan and move it over just a little bit and then zoom in. And we're going to take a look in the brain right now. And we need to zoom in because a lot of the structures in the human brain that deal with the endocrine system are going to be very, very tiny. So right here we have the pineal, and the pineal is a small gland that helps dictate our wake and sleep cycles. It produces hormones that tell us, hey, we need to be awake. No, you need to go to sleep. When we can zoom in a little bit further, there's pituitary gland, and this is going to be a pea-sized tissue, and it's inferior to the hypothalamus, and this produces hormones that deal with our growth cycle from infant to adult. We can move more inferiorly and take a look at, say, the thyroid gland, which can be easily identified because it's kind of butterfly shaped. It actually has several smaller structures, but as long as you can identify something that's butterfly shaped, you'll be in good shape. And the thyroid produces hormones that deal with our metabolism. There is the thymus. It's a little more anterior to some of our structures that we learned about in the cardiovascular system. And that one will help regulate a variety of other biochemical functions in our body. Sitting more superior to our kidneys are going to be the adrenal cortex. We will have a left one and a right one, and these aid in digestion, and it also assists our pancreas, which results in helping maintain our blood sugar hormones. And then moving down south, so this is actually going to be a male 3D model. Innerbody.com, I don't think produces a female one just yet, but there's the testes, and that will and those are part of the gonads, and those are all, well, there for sexual reproduction. But I highly recommend taking a look at our OER resource, innerbody.com, and explore the endocrine system on a structural level and be able to practice your identifications and learn more about these very specific functions because the write-ups are actually really detailed. I find they're a little bit better than our book. And then go into the virtual dissections and try to make identifications on the virtual cadavers using the 3D model as a standard of comparison. Another task that I'd like for you to accomplish this week, as you are not only identifying the different structures, but I'd also like for you to take a look at the histology that the endocrine system has that can inform us on some of these much smaller structures that are really hard to see in dissection, but we can see them in histology slides. And I've got this virtual slide box, open educational resource, one that we've been using on and off throughout the class. And you can click onto it and it brings you to a variety of good high resolution slides. These are sorted for the endocrine system. They're organized by pituitary, thyroid, parathyroid, both the thyroid and parathyroid together with the thymus, so that way you get a nice comparison between the different structures as they are all interlaced. The adrenals and pancreas. And I'd like for you to be able to take a look at, say, like the pituitary hormones. That will show a feedback loop, so like what different effects are and what structures are being affected would be really helpful to help to study. If you're wanting to learn more about the pituitary and how to make some identifications, you can go and take a look at some of these slides and zoom in and really explore and take the identifications and put that into a conceptual model that you can learn and be able to use as a way for to be able to communicate these. You click on the thyroid, and the thyroid has a nice description right here. You can identify things like the follicles, where the hormone is actually stored. Sorry, got a little tongue-tied right here. And the capillaries that will help keep those follicles functioning. And even the adrenals right here. There's the cortex found throughout here that synthesizes and secretes things like steroids. I think that's really neat. And so that's really what we're going to be working on on a histological level. So, you're going to get your virtual dissections and you're in a body. So that's going to look at the broad scope of this body system. The histology is going to look more at the smaller structures and how to identify them. And then we're going to then take some experimental design and apply that. So one of the things that I really want to be able to show you this week is that when we take a look at the endocrine system, there's a molecular component to it, basically biochemistry. In Anatomy and Physiology Part 1, we worked with that. We acknowledged the endocrine system secretes a variety of different hormones, and that the hormones develop a cause and effect relationship to our bodies and helps us maintain homeostasis so we can navigate the world around us. This week, we are going to take that a step further and really investigate and delve into that cause and effect relationship. But right now, I want to be able to show you a little project I made, a little scientific model. And this is the model of propylurocell, also known as PTU. It's a synthetic medication used to treat hyperthyroidism, and I made it out of a molecular model set we typically use here in our online chemistry courses. But when we take a look at this ball and stick model, we can see that there's a lot of different elements that when they bond together, they form compounds. And here you can see 10 hydrogen indicated by the white balls. Black will represent carbon. The blue will be nitrogen, and there's only 2 of them. And there's only 1 red oxygen and 1 sulfur. And PTU, again, is a synthetic medication. We make it in a lab, and we use it to treat hyperthyroidism, a condition where the thyroid gland in our bodies, that's part of that endocrine system, produces too much of the thyroid hormones. And its diagnostic characterization is that of you have an overall lower body temperature and lower ATP going on. And when it becomes really problematic, you will actually start to develop an enlarged thyroid gland, also known as a goiter. But in this week's lab, we are going to want to deploy our experimental design that we encountered earlier in the course. And those techniques will be expressed and utilized very heavily in our lab assignment because we want to be able to understand that relationship. If we change the concentration or introduce variables that impact the endocrine system, what will occur as part of our investigation? For an example, lower body temperatures can be sped up by increasing hormones that correspond with metabolic rates. It will induce shivering, and that will warm up our bodies. But it also will interact with body systems such as our respiratory system, that deal with respiration, because our bodies are being accelerated because of the introduction and secretion of changes of our hormone system. And I think that's really fascinating because, again, homeostasis is all about balancing our bodies. That way we can interact and navigate the world around us. So if we introduce too much of a specific hormone, we can cause other body systems to develop a cascade effect and cause very problematic issues. But if we better understand on how that cause and effect relationship works, we can then work with it and develop these synthetic medications. When we take a look more in depth in this lab assignment this week, I want you to be aware that there's going to be an inhibition of thyroid hormone production. You see, PTU works as a blocker on the thyroid gland's ability to produce a thyroid hormone. It helps control it, and it specifically inhibits enzymes like thyroperoxidase, which is necessary for that synthesis of the thyroid hormone itself. So if you're having troubles with your thyroid, you may be prescribed this synthetic medicine to be able to help control and prevent that enzyme to be formed at a less dangerous or problematic level. There's also going to be a cause and effect relationship in being able to understand the reduction of circulating thyroid hormones. If we use PTU, it will reduce the levels of circulating thyroid hormones within the bloodstream because it's trying to inhibit that formation of the enzyme, which will lead to the hormone. And then it will help with overall symptom improvement. You need to lower your thyroid hormone levels. It helps alleviate symptoms. It prevents the formation of those goiters, but it also helps with the changes in rapid heartbeat, weight loss, tremors in your hand, because there's an imbalance within your own nervous system that utilizes these types of hormones. Heat intolerance, you will have a more regulated body temperature. And in this case, PTU can also change oxygen consumption. And we're going to take a look at that utilizing lab mice. We're going to give one group PTU, one group without PTU, and I believe a third group where we actually give them the opposite of PTU, which is going to be like caffeine in high doses, just to see what that relationship is between body temperature, oxygen consumption, and these changes to the endocrine system. Overall, utilization of things like PTU is really great because it shows us that we are getting better at learning more about human anatomy and physiology on a very small level. I think the endocrine system is a very complex system because we don't know much about it because there's so many different biochemical molecular reactions that are occurring. But without those reactions, we would not be able to maintain homeostasis. And this actually, again, allows us to be able to bring forth new information in anatomy and physiology. One, we did a survey of the endocrine system, and in case this is a new body system for you, you're fully supported in this week's lesson. But in A&P1, we took more a look at the hormones and less about the glands. And this is where we're going to actually pull that previous knowledge and then apply it further. But again, if this is new content, you will be brought up to speed and still be able to meet these learning outcomes this week.